So I know you already have a sense of how to do this math, but using the PTVn tables is a little bit different. And I'm going to show you a new way to set up your calculation so that it's not quite as much writing, because I know we're getting a little sick of this whole like writing it out every single time. I think we are starting to like understand it really well, and so it's like beginning to be appropriate to sort of graduate away from that format. I know some of you are very excited about that, but I got to show you how to do that, and I'm going to bridge that gap for you in a really comfortable way, hopefully. So first, what is a PTVn table? As you can see, it is a way of keeping track of pressure, temperature, volume, and amount of gas. Yes, the N is amount. Just kind of go with it. There's a good reason for it that we'll talk about probably when I get back. And you can also see that there's 3 rows for initial, final, and effect. Initial and final are probably pretty self-explanatory. It's the initial condition according to the question, and then final is the final condition according to the question. So let's fill those in real quick. We know that a sample of gas is occupying 150 milliliters at 298 Kelvin. So milliliters, that is a volume. So I'll say 150 milliliters is my initial volume, and 298 is the temperature when the volume is 150. So that'll be also initial. Then we want to know what is the new volume when the temperature is increased to 323 Kelvin. So that's right here, 323 Kelvin. So we can see that our temperature is going up. We know, all right, this is where our effect row comes in. We know that when temperature goes up, what effect does that have on volume? Well, that also makes volume go up because this is a directly proportional relationship, right, between volume and temperature in Kelvin. So I know T up, V up. And since V is going up, I know that, I don't know what my answer is yet, but I know it's going to be bigger than 150, right? So I'll leave that blank for now, and I can fill my answer in there once I get it. But let's do the math. Now I'm going to do the math 2 ways. The first way is going to be the way that's very familiar to you. It's this proportionality math that we've been doing for a while. And then I'll show you another way to do it. So first, we'll take this 298 Kelvin, and we'll say that is the temperature when the volume is 150 milliliters. We know that we are increasing the temperature to 323, and we want to know what is the new volume. So the way that you know to do this is you have to figure out what the scale factor is between that 298 and that 323. And of course, the way to do that is to do a little bit of division. So I'll take 323 divide by 298, and that will give me 1.08. That is the scale factor there. So I must also have the same scale factor over here of times 1.08. And now when I punch in my calculator 1.08 times 150, I get an answer of 162. All right, so that is the same way we've been doing math for the whole school year, right? Since we did density, we've been doing math like that this whole time. But I want to stop for a second, and I want you to pay attention to the specific steps that we punched into our calculator. All right, the first thing we punched in our calculator, remember, was we needed to find the scale factor, this 1.08, and we did that by taking 323 divided by 298. That was the first thing we did. And once we punched that in our calculator and we got 1.08, we then took that 1.08 and we multiplied it by 150. So really we did 323K divide by 298K multiplied by 150 ml. And that's all that we punched in our calculator. All right, 323 divided by 298 times 150. All right, I think you guys are really going to like this because I'm about to stop requiring you to do this, at least for gases. All right, we don't have to do that anymore. We have a shorter way to write this, and that's going to be like this. You're going to take the thing that you're starting with, our initial condition of the thing that we're solving for, and we're going to multiply it by a ratio of the variable that's changing. So in this case, I'm going to multiply it by a ratio of my temperatures. My temperatures are 298 and 323. So we're just going to put 323 over 298, multiply by a ratio of the thing that's changing, and then you just punch that in your calculator. You can go 150 times 323 divide by 298, and that will give you the same answer, of course, of 162 milliliters. So you are free to show your work like this from now on. Notice I'm still putting units on all of my answers. Sorry, I'm still putting units on all my numbers. Okay, that rule hasn't changed, but we are able to graduate from this format now. We don't have to do that anymore. So the thing is, we have to be able to decide how to set up this ratio. Because you notice I just put 323 over 298, but how did I know to do that? Well, that was really one of my only two options. I could either have done 323 over 298, or my other option is 298 over 323. So how did I decide which one to do? Well, when we do this proportionality math, it's really obvious which way we have to divide, right? Because we just know that I'm trying to find this scale factor between 298 and 323. So it's very clear. It's just do 323 divided by 298. But when you abandon that format, it becomes a little bit less obvious. So here's what we have to do. All right, I'm going to back up a little bit. And I'm going to say, okay, we started with 150. Let's pretend that that isn't there. We started with 150, and I'm going to multiply by a ratio of my temperatures, right? So like I said, my two options are either 298. My two options are either 298 over 323, or I can do 323 over 298. How do I decide? Well, the answer lies in this effect row, all right? Because I have already decided that my volume should be increasing because my temperature is increasing. So if I know that T up, V up, and we know that because we watched the video with the balloon, right? And we know that they scale proportionally as well because we drew the graph, then I know that my 150 number is going to get bigger as a result of my temperature increase. So if I know that my answer has to be bigger than 150, then that tells me automatically that I should put my 323 on top of my 298. Because if I put my bigger number on top, right, my 323 is the bigger number, if I put it on top, that makes this ratio greater than 1. And if I multiply 150 by a ratio that is greater than 1, then I'm going to get a number that is bigger than 150, right? Whereas if I did it the other way, if I did 298 on top of 323, you see that ratio is smaller than 1. And so since it's smaller than 1, that would give me an answer that is smaller than 150. Let's punch it in real quick so you can see what I'm talking about. So you get 138. So if you got 138 as your answer and you boxed it, then you should have like alarm bells going off in your head because you already decided, because you filled in your PTVn table, that the volume should be going up. And going from 150 to 138 is not going up. So that can't be right. You see, so the effect row is super, super important because it tells you how to set up your ratio of the thing that's changing. Do you put your smaller number on top or your bigger number on top? If you decide that your initial condition or your initial number should get bigger, right, then you know you're going to put the bigger number on top. If you decide it's going to get smaller, then you put the smaller number on top. And that's it. And that's super, super simple. And now it's really easy for us to show our work, and you don't have to write as many steps. I think you guys are going to be happy about this as long as you, I hope this video is clear. Oh, I really hope it is. If not, I'll have a key up with just the answers. I won't have the work up until Friday. But once you have that, you can compare your work and you can see, make sure you're doing all right on this. By the way, fair warning, on Friday, you're going to have a mini quiz. And the mini quiz is not going to be any math, I don't think. There's no math on it. It is just conceptual stuff. So those particle diagrams and the particle level explanations, talking to me about collisions. You also got to know what the graphs look like. So make sure that your graphs are good. Yes, that you have all those graphs, you know what they look like, you know when Kelvin is necessary to be used, and all that kind of stuff. All right, so all this stuff, except for the math, is fair game on tomorrow's mini quiz. Cool. And then when I get back, we will rep PTVn tables a whole lot, and we got a little bit of more math to do. Cool. All right, so stay tuned. I'll have another instruction sheet posted for you on Friday. Get as much of this sheet done as you can in the time that you have. And yeah, that's all I got for you. Thank you for working hard today, and I will see you when I return.